they would like to maximize, right? And in order to do that, so they would take, and the very intuition of the problem for the firm side is quite similar. So that there is some kind of benefit. I mean, there is a reason why firms performs production. So the idea here will be to obtain some kind of profits by producing and supplying the goods. But again, we will be operating in a perfectly competitive market. And what does perfectly competitive market mean in the first place, right? What do we understand when we talk about a perfectly competitive market? Or maybe let me ask you this question. So what comes to your mind when we speak about perfectly competitive markets? What do you think? Full knowledge is one of the features of the perfectly competitive market. That's true. No monopolies. And Utku, what would no monopolies mean for the individuals? So what is the consequence of no market power? Or maybe let me choice regarding what? So anyways, so the first thing that has to come to your minds when we speak about perfect competitive market is that all the individuals choose quantities but not prices. Okay, so because we have no control, so the individuals have no control over the prices because they are atomic units, right, in the market. Because there are many households and many firms that produce or demand in this particular market. So that everybody takes prices as given, as if they were given, right? So they would just go into the market, look at the market prices, and try to operate on these given prices. So when we speak about perfectly competitive market, this is the first thing that has to come to your mind, all right? For the household, it was the case, and for the firms, when we speak about perfectly competitive markets, it's again the same thing. So that the firms, when they try to make their decisions regarding their supply, they also take prices as given. So we will first have a look at the production process itself. Then we will do the same thing for the firm, basically. So we will try to understand how costs change when the production levels change. And we will also try to understand how the production quantities would change if we use different inputs in the production. So that in the firm's problem, we are going to see that it's going to be a profit maximization problem now instead of a utility maximization, which is a more concrete term as compared to utility. And in order to maximize profits, the firm now has to decide which input to use in order to produce a certain amount of goods. All right. So that, remember, in the household side, the household had to choose among different goods or services. But now in the firm side, firm knows what he's supposed to, or what it is supposed to produce. But the question is, how much of each input to use in the production. So that's the main problem here. So the production, as you remember, is a process that there are some inputs that we would like to combine, right? So there we might use different inputs. What were these inputs? Do you remember? Or we also call them labor, land, and capital, right? But here, in this lecture, we will take land as given. We are not, because land markets are a bit different. So we won't take land into the equation here, but we will focus on the decision between labor and capital, all right? So we will assume that the production is held only by using capital and labor, and the firm has to decide how much capital or how much labor to use. So the firm that we are talking about is an organization that appears when a person or a group of people, which we call as entrepreneurs, to produce a good or service to meet a perceived demand. So there is a demand for a particular good, and that's the reason why we think that we can get some profit out of it. So we observe that people demand for something. So it doesn't have to be necessities, but it could also be any type of demand, right? So if there's a demand, then some entrepreneur could come together, or a single entrepreneur can appear in the market and say that, okay, I would like to produce this good. And why do I produce this? Because I want to make profit out of it, right? And the three problems, remember, we had three problems also for the household, but for the firm side, other problems are how much output to supply. So this will be related to the prices of the goods and services. That, remember, again, the firm takes its prices given in a perfectly competitive market. The firm should also take into account the prices of capital and labor, right? Which are, what is the price of capital once again? How do you call it? So what do we pay to capital in return? So you're a firm, you have to use some kind of capital, right? So you have to, I don't know, you require some financial capital, for example. What is the price that you pay in return for using this capital in production? Investment is a decision that you make, and it is made by the households, right? So people would make investments, and when the firm takes this investment, it means that it uses this investment as capital, right? So for the households, money is not a price, money is a measure, right? So it's some kind of things that we can store our wealth in. But let's talk about investment. So households make investments, right? So that's what we see, what we saw in the last lecture. So, and they do investment. What does investment mean? For example, they buy some stocks, right? In the stock market, let's say. And by making this investment, they get what? Some kind of return. And this return was determined by a price. And what was this price? What do you get for your investment? So this, it is an interest. It is the interest. So that the price, so interest is what you get out of your investment. And if we came up with a price that explains the rate to which we can get interest out of our investment, then we could have a price. So how is this price called once again? It is very close to interest, but it has to give me a rate, right? That for each unit of my investment, what do I get? So you put, let's say, 1,000 liras to a bank. So what do you get? It is the interest rate, right? Okay, interest. So suppose that, so let's say the policy interest rate is around 15% right now, right? So suppose that this is the annual interest rate. And so if you put 1,000 liras into a bank as investment, what do you get at the end of the year? So you have 15% interest rate, right? Annually. So then if you put 1,000 liras into a bank to an investment account, yes, you would get 1,150. And this 150 is your interest, right? And what is the interest rate in this case? Exactly. So no, so I mean, don't think about inflation for now. So because inflation is not. So I'm not talking about real interest rate. I'm talking about the nominal interest rate. So they are different, but we are going to see about it in the macro part. But 15%. So what does this 15% tell me? So it tells if I put 1 liras, I would get 0. Like so the 15% or 15 divided by 100 in return to this one lira, right? So in a sense, it is the rate to which I get return from my investment, which gives the price of my investment. All right. So then again, the firms are the units who will take these investments that households make, right? And they will use this as capital in the production, right? To translate this 150 or 1,000 liras, let's say, they will use this 1,000 liras in their production, and they will make some profit out of it, but they also have to pay to the household the price of their investment, which is 15%, right? So that when the firm makes the production decisions, so when it should take or it should require some capital in the production, and one of the prices that it also has to take into account, okay, what is the interest that I have to pay to this capital that I use in my production, and so that the price of the capital is the interest rate, because I have to pay back this investment to the households. Is that clear now, or do you have any questions? Okay. So then the second problem is, okay, if I know how much output to supply, but again, so I have to know the price of factors of production, namely the labor and capital. And so then I have to make a choice, how much of labor, how many labor should I use, should I hire in order to undertake my production? And how much investment should I include in my production, right? There are different types of firms, some of which might use a lot of capital. For example, maybe they use a lot of robots in their production. And there might be others who might rely more on the labor force or human labor in the production. So these are different technologies, and firms have to choose a optimal strategy in regard to how much labor to use and how much capital to use in their production, right? So in return, it will explain us, so what would be the demand for inputs or factors of production that should be determined again by the firm. So let us remember some concepts once again, so that the profit is the objective now. So it is the one that we would like to maximize. A producer has to pay more than total interest to households to get their savings. What do you mean by that? So, I mean, if we know that there is a market interest rate, right? So, and if we know that the capital markets or financial markets are also perfectly competitive, so that there are no frictions, then we can say that the firms can also obtain the investment with the market price, which is the interest rate. Alperen, could you explain more? What do you mean by this question? I mean, I would like to understand it better so that I don't give any wrong answers to that. You can also use your mic if you like.
Sesim geliyor mu hocam?
Yes.
Şeyi anlayamadım. Faiz oranlarıyla üreticiler arasındaki bağlantıyı anlayamadım da yani anlayabildiğim bu oldu. Yanlış anlamışım sanırım.
Yok şöyle düşünelim. Şimdi hani aklımdaki soruyu az buçuk anlayabiliyorum diye tahmin ediyorum. Anladığım kadarıyla cevap vereyim. Şimdi piyasalar hani tam rekabetçi dediğimiz zaman aklımızda ne? Piyasada oluşan bir fiyat var ve herkes bu fiyattan alıp satabilir. Doğru mu? Şimdi bu capital market dediğimiz şey de aslında aynı şekilde işleyen bir şey. Yani mesela hiçbir üretim riski olmadığını varsayalım ya da default risk dediğimiz hani batma riski olmadığını varsayalım. Bu durumda piyasada oluşan faiz oranı neyse bir firmada bankaya gidip aynı faiz oranından kredi çekebilir örneğin. Doğru mu? Buradaki temel
Evet.
varsayım bu. Ama işin içine işte üretim riskidir, işte default riskidir falan girdiği zaman biz bu taraflarına çok girmiyoruz. O biraz daha finansın konusu. Öyle bir durumda evet hani eğer senin mesela bir üretim riskin varsa o zaman banka sana daha yüksek bir faizden kredi verir örneğin. O zaman senin ödediğin interest rate de fazla olmuş olur. Doğru mu?
Hı hı.
Sorduğum bununla mı alakalıydı yoksa ben bir şey mi kaçırıyorum?
Ya hocam temel olarak buydu evet. Ama
Anladım.
biraz daha anlamam lazım yani.
Şöyle aslında
Anlayamadım.
hani bu özellikle ben size şunu anlatmaya çalışıyorum. Interest rate dediğimiz faiz dediğimiz şey aslında bir malın işte pizza fiyatından farklı bir şey değil. Bizim işlediğimiz kadarıyla. Tabii arkasında çok farklı şeyler var. İşte para arzı bunun bir tarafı, efendime söyleyeyim finans piyasalarında oluşabilecek sıkıntılar mesela bir finans krizi gibi bir durumda oluşacak faiz oranları çok başka bir şey. Bunun içerisinde para politikası var, enflasyonu var, şusu var, busu var. Tabii ki bir hani mal piyasası gibi doğrudan incelenemez. Ama bizim burada hani derdimiz olan şey en temelinden hani basit olarak bir sermaye piyasasını nasıl anlayabiliriz diye düşündüğümüzde. Burada oluşan bir fiyat vardır. Bu da piyasada oluşan bir fiyattır. Nasıl oluşur? Mesela eğer hane halkının tasarrufları artarsa bu aynı şuna benzer diye düşünüyoruz burada. Piyasadaki investment'ın artması örneğin faiz oranlarının düşmesine yol açar gibi düşünebiliriz. Çünkü para bolluğu var piyasada. O zaman faizlerin düşmesini bekleriz gibi. Böyle basit bir algıda düşünürsek, hani basit bir ortamda düşünürsek faiz oranı dediğimiz şey de normal yani bir mal fiyatı gibi ya da bir hizmet fiyatı gibi yine piyasada oluşan bir fiyat gibi düşünüyoruz. Yani bu şuna dönüşüyor aslında. Faiz oranı dediğim şey benim aldığım her bir sermaye birimi için ödediğim fiyata dönüşüyor. Anlatabildim mi?
Anladım hocam.
Tamamdır. Şimdi, yes. So again, the objective of the firm is to maximize the profits. But what is the profit composed of, right? On the one hand side, we have total revenues. So what is total revenue? So let's say Q is the total production or total supply of the firm, and let P be the price of this product that the firm tries to understand how much to produce. The total revenue is the quantity that I produce times the price of this good, which is again determined in the market. But the cost is a bit more complicated than this. So when we speak about costs in economics, what we have in mind is not only the out-of-pocket costs, so it's not only the cost that we pay for, let's say, the factors of production, but there are also opportunity costs or implicit costs, as we call it, that should also be taken into account. So what these opportunity costs be? For example, I mean, suppose that you finished your undergrad and you can work as a engineer, right? But then there is a market opportunity, so you could also start a firm and make production. So there are two alternatives. So you either work as an engineer, and let's say you can make 10,000 liras in the market. Let's suppose that. I don't know how much you guys can make as a freshman, but let's suppose that it's 10,000 liras. Okay. And there's also another alternative, right? So you can go into production, so you can buy some capital and you can hire some labor, right? And you can make production. Okay. So what is the minimum amount of profit that they would like to obtain in order to choose production instead of working as an engineer? What do you think? Any idea? Soruyu anlayabildik mi? So the question is the following. So what I say is that there are two costs. One is explicit, okay? So this is what you pay for the factors that you use in production, right? So typically, so we are going to see more into detail next week about these costs. But typically what we have is, so for example, so you hire N number of workers, and for each of them, you have to pay some kind of pay, right? And then you hire some capital, let's say K, and then you pay R. Okay, so this is your explicit cost, okay? Because you directly pay it from your pocket. So there might also be some fixed costs, for example, that in order to enter the market, you have to learn about the market and you have to spend some time. So maybe you have to make some advertisement in order to operate in this market, so that there might also be some fixed costs. So these are all explicit costs, okay? But what I say is that when you make your production decision, there is another type of cost that you have to take into account, which is the opportunity cost or implicit cost, that you think, what would be the best alternative if I were not the producer? So if I didn't do the production, so there's some other opportunities that I could be doing, right? And for your example, suppose that now you're an engineer, hopefully in a couple of years, and suppose that the best job that you can find gives you 10,000 Turkish liras. It could be more than that or less than that, I don't know, right? So then the question is, what should be the minimum profit that will make you decide that you do the production, so you become an entrepreneur and you make production, instead of working as an engineer? So what would be that? Okay, yeah, that's the opportunity cost. But the question is, again, şunu soruyorum arkadaşlar. Şimdi diyelim ki siz mühendis oldunuz ve bulabileceğiniz en iyi iş diyelim ki size 10.000 lira kazandırıyor ayda. Şimdi bir arkadaşınız geldi, ya benim şöyle bir iş projem var. Şunu yapacağız. Mesela bir startup başlatacağız. Tamam mı? Şöyle bir app yapacağız. Şimdi bu app'ten kazanacağınız minimum para, minimum kar ne olmalı ki siz Aselsan'da çalışmak yerine örneğin bu startup'ı başlatmak isteyesiniz? 10.000 değil mi? Yani en azından burada kazanabileceğin parayı kazanmak istersen, eğer 10.000'den fazlaysa ne ala. Ama minimumunu sorduğum için 10.000 lira diyebiliriz. Then what is included in total cost is also this opportunity cost that one might have. So we don't directly calculate this opportunity cost when we make our decision, but we implicitly have this in our calculation for economic profits, right? So that when we speak about profit, so in short, we just say profit, but what we mean by that is the economic profit. So it's the profit that take both explicit and implicit implicit costs into account. So when I will say that you have a zero profit, okay, so what I mean is that it is zero economic profit, all right? So what it means that you're actually making 10,000 liras. Because it was part of your opportunity cost, so the economic profit is still zero. Is that clear? Yani ben size bu firmanın karı, ekonomik karı sıfır dediğim zaman sizin aklınıza gelen şey şu olmalı. Demek ki bu adam başka bir işi seçmiyor hala. Yine üretim yapmayı seçiyor. Demek ki opportunity cost'ta yani alternatif maliyeti de bu karın hesaplanmasında göz önüne alınmış demek. Yani eğer bu adamın fırsat maliyeti dışarıda kazanabileceği en iyi para 10.000 liraysa demek ki bu adam aslında 10.000 lira muhasebe karı yapmış. Yani aslında cebine 10.000 lira girmiş. Ama toplam karı biz fırsat maliyetinde göz önüne aldığımız için sıfır olarak karşımıza çıkmış. Anlaştık mı? Sorusu olan var mı? Okay. So, one distinction that we typically make when we take production decisions into account is between the short-run decisions and long-run decisions. Guess what? You could think like that. So, because if you make, let's say, 5,000 lira, so what is the point in making production, right? So you could just go to market and you would work as an engineer instead, right? So that this is the minimum profit, they would allow you to continue your production. So that when we speak about zero profit, it means that you are still okay to do production, but you are not making more than what you could have made if you worked as a labor in the labor market. So, okay. So, again, we have to make a distinction between the short run and long run. And the main distinction is in the following. So, so the meaning of short run, so it's different periods of time that we take into account, but we cannot separate it. So it might depend on the type of production or the conditions in the economy and such. But what we understand from short run is a period of time that I cannot change the scale of production. So that, for example, let's think about the scale as the size of my production site. So suppose that we are producing in a factory, and in the short run, what I mean that I cannot change the scale. So I cannot buy, let's say, new robots in this production site, or I cannot increase the size of the production factory, let's say. But there's only one thing that I can change, and generally it is the amount of labor that I hire. So even if I work in the same factory, for example, I can tell that, okay, guys, we have a lot of production, so we would like to increase the production, so you are making overshifts, for example. So in the short run, I can typically change the amount of labor that I can use, but the amount of capital is typically fixed. And if you also include, let's say, land, you also think that in the short run, land is also fixed. But for now, we forget about land. And what we say that when we have short run, when we speak about short run, what we have in mind is that the capital use is fixed. So we are working in a fixed scale, but we can play around with the amount of labor. Okay? So we can increase the amount of labor if we face a lot of demand, or we can decrease the amount of labor if there is not much demand for our product, right? But in the long run, everything is variable. So we can change our labor, we can change the amount of capital, so we can make some more investment in our production, right? So we can, I don't know, so buy a new technology that will allow us to produce more efficiently, or to a bigger amount. Or we can also play around with land, so we can buy, I don't know, a new farm that would help us with the production, depending on what kind of production we are talking about. So the production technology is another important factor that the firm should take into account. So when we speak about a production technology, what we typically have in mind is a function, right? So suppose that Y is our total production. And when we think about production technology, it's kind of a relationship, a quantitative relationship between input and output. So my output is Y now. And I say that there's kind of a relationship between the inputs that I use, which are capital and labor, and the output that I produce. So this production function, as we call it, defines the production technology. For example, typically we use a production function that looks like this, right? And these parameters that I use in the production function actually represents the production technology that I have. So in economic discussions, we also make a differentiation between a comparison between the technologies which are more which depends more on the use of labor, right? So that, for example, if you think about agriculture, the production function in the agriculture depends on the labor more heavily, and these kind of technologies we call as labor-intensive technology, okay? But there might be other kinds of technologies. For example, if you are producing microprocessors, and the use of labor is less important, but what is more important is the capital that you use in your production. And then these type of technologies are called as capital-intensive technologies, right? So again, we talked about production function. It is the quantitative relationship between inputs and inputs which actually defines the production technology. So it's like a representation, mathematical representation of the technology that the firm. So before we understand the nature of the profit maximization problem, we first have to make some definitions as we did for the household part. And the first is the marginal product. So it is a similar concept when compared to marginal utility. So the marginal product simply refers to the additional output that can be produced by adding one more unit of a particular input when everything else is the same. So for example, if you are talking about the marginal product of labor, so it refers to the change in the total production when we add an additional labor into the production, okay? So suppose that we have a certain amount of capital that we use, so we keep this fixed, and we add an additional labor to our production. So we would expect our total production to increase, so total amount of product to increase, and this change in total production is called as marginal product, okay? So average product, as the name already suggests, is the total production divided by the number of input that we use. So if we are talking about average product of labor, once again, so if we produce, let's say, 1,000 units of a certain output, let's say, I don't know, let's suppose that we produce 1,000 cars in a given period of time, and if suppose that we have 100 labor in the production side, right? Then the average product is 1,000 divided by 100 labor, which is 10 cars per labor, so which would give us the average product. So similar to law of diminishing marginal utility, we also expect that this, as we increase one of the factors, let's say labor once again, so as we keep increasing the amount of labor in the production, so we would expect the total production to increase, but with a decreasing rate, right? So that maybe it's better to draw it here, but we are going to see it once again. So suppose that, oops. So we have labor, and I will try to understand the total production as I increase labor, and suppose that I keep the amount of capital as fixed. Okay, so what I expect from the technology is the following. So as I increase the total, the amount of labor in the production, so I would expect the total product to increase, but this increase is at a decreasing rate. So that each additional labor contributes to the production, but the contribution by additional labor is decreasing. Okay, so that's what we have in mind when we speak about the law of diminishing returns. So let us see an example of the of a production. So here it's the amount of labor that we hire, so that these are employees. And here we have total product. So this is like we are producing sandwiches, and it's the total product in a given hour. Okay. And then here on third and fourth columns, we will try to calculate the marginal product and average product. So if there are no labor units, so there is no change in the labors, and total production is 0. And since we didn't add any labor, so there's no marginal product or there's no average product, right? So now let us look at what happens to our production if we hire one person. So this person can produce 10 sandwiches in an hour. So the marginal product of labor for the first employee is the change in total product, which is simply 10. And the average product, so we have total product is 10, and we have only one labor, so that average product of labor is 10. And then we have the second guy. So now we actually see that the production actually increases to 15, so to 25. So the change is 15. So now in this example, we actually see that the marginal product of second labor is even higher than the first guy. So it is a bit different what I drew before, so that in the beginning, the total increase is somehow increasing. And the average product is actually just this 25 total product divided by 2, which is 12.5. So for the third guy, then the increase is 10. So the marginal product of this guy is 10. And we can calculate the average product of labor as the same. But now we see that the marginal product has started to decline, right? And as we add more labor to production, we see that the marginal contribution of additional labor is decreasing, so that we are at the same decreasing or diminishing return case once again. So this is the total, simply total product. Okay, and this is labor. So we can also see it graphically more generally here, so that the total product is changing, and for the first, from first guy to second guy, the marginal production, the marginal product of labor was increasing, and this is the part we see here. But after a certain point, we see that the total production starts increasing, but with a decreasing rate. That's why we have a negatively sloped marginal product curve. And for the last guy, for the sixth guy, so even we added the sixth labor, we see that his contribution to production is simply 0, right? So that the marginal product of labor for this guy is simply 0. So we can also derive the average product curve. And we see some regularities here. So let us try to derive it ourselves once again. Or maybe it's better here. Okay. So, so the total production, as we increase the number of labor, is increasing up to a point, and at a certain point when we hire 6 labor, is simply it reaches to a maximum, and after this point, increasing the amount of labor does not contribute to production at all. So now let us also derive the marginal product curve. So as long as, so remember that at this part, the marginal product was increasing. So until this point, we would expect to see a marginal product that is increasing, okay? But at this exact point, so the curve actually bends, and so suppose that it's a continuous curve. What is the mathematical expression that you would expect to see here? So what can you tell about this point? So maybe you might start thinking about it, and we can talk about it later. So, but what we know is that marginal product is increasing until this point, and after this point, the marginal product starts to decrease, and at this maximum level, so suppose it's like this, it reaches to 0. Alperen, you're right. So, but what happens to the average product? So let us look at the table again. So here, so until the third guy, the marginal product was increasing, right? Okay, maybe this table is not good enough because it's not as continuous. Okay, it also decreases here. That's not good. Okay, so the table doesn't help us quite a bit, but we can try a different example. And what we would see is that although the marginal product starts decreasing after this point, we should see that, maybe I can derive it with a different. So this is the marginal product of labor. What we are supposed to see is that, so the average product of labor is increasing, and it reaches the maximum at a later point than the marginal product of labor. And when it is exactly the same with the marginal product of labor, since the marginal product of labor will start decreasing after this point, also does the average product of labor. Okay. How can we explain this? So why average product of labor is decreasing after the maximum point of the marginal product of labor? So in order to understand this, I mean, the straightforward explanation is that, let's look at this point. So here, marginal product is higher than the average product, right? So as long as the additional unit gives a higher contribution than the average rate, although it might be decreasing, still the contribution is still higher than the average product, and hence, although marginal product might start decreasing, average product might be keep increasing until the point where the marginal product is lower than the average product, and after this point, average product will also start decreasing since the additional units, the contribution from additional labor is lower than the average product of labor. So if we marginal product. So what you would care, Eren, we are going to see about it. It is not only the marginal product or average product, but it is the, so as in the household case, it is the, it is somehow marginal product, of course, but for each unit of labor, I pay a wage, right? So this is the marginal cost of labor, and in return, I get some price, and I sell some quantities, right? So the optimality actually, so the profit maximization decision will depend on the relationship between these marginal costs and the price of the good that I sell. So if I would give a short answer, then it would be the marginal product, but also the behavior of average product also is important. But as the firm, what you care most is the marginal product of labor. So this point, okay, maybe before that, so how could we drive the marginal product of labor? So, I mean, if we have a discrete relationship, so that like this table here, so that we could easily get the marginal product of labor by looking at the changes in total product. But if we have a production function at hand, let's say my production function is something like this, then how can I drive the marginal product? For example, if I would like to derive marginal product of labor, do you have any guess? It's the partial differential, or is this the first derivative of the production function with respect to labor. So this gives us the marginal product of labor. And what do we know about this maximum point here? So it is the change in marginal product of labor is actually 0, right? Because this is a local optimum. And since I know that this was the first derivative of the production function with respect to labor, then I know that it is the second order derivative of the production function with respect to the labor, then this has to be equal to 0. So if you look at this graph, then since this is the total product, when I keep the capital as fixed, then exactly at this point, what I know that is the second order derivative is actually 0. Okay. And what do I know about this maximum point? So here, what I know that marginal product of labor is 0, which was the first order derivative of the production function with respect to labor. Okay. All right. So this is the general behavior of the production function. So that's what we expect from production process. But so we know that the firms will operate on the point where the law of diminishing returns would hold. But why do you think that when we derive these, we have an increasing portion? So how can we understand this increasing marginal productivity? Like in real terms, what do you think? So in order to understand that, let us think about the sandwich example again, so that we are operating in a fixed case, so that we have a let's say a buffet, or I don't know, a small restaurant where we only produce sandwiches. Okay, we have all the equipment that are needed, but they are fixed in number, so that we have a fixed place, maybe one table or two for producing these sandwiches and such. So that when we start with only one guy who would produce these sandwiches, then we see that, okay, one guy can produce, if he works alone, only 10 sandwiches in a given hour. But what happens when I add the second? So I see that now if they are combined, so they can produce 25 sandwiches, which means that the productivity of one neighbor, the average productivity, is increased when I add the second person. So everything else is the same. So we still operate in the same place. So we still use the same equipment. But only by adding one more person, I see that the productivity of labor has increased. So what do you think? What could be the reason? Chance could be, but Fatih has a good answer. It could be teamwork, right? So maybe instead of using the term teamwork, let's say specialization, right? So that when a single guy produces these sandwiches, so she has to cut the salami, she has to cut the tomatoes, or she has to clean all these vegetables and whatever. She has to cut the bread and whatever. So it requires different types of works, right? But when we have the second guy, so we can say that, okay, you only work with the bread, so you only cut the bread, and the other guy does the vegetables and stuff. For the Cruise and Friday example, it is kind of similar. Yes, it also includes some kind of specialization. But there we talk about trade a bit more, so it is also a bit different. But you're right, Eren. So in terms of specialization, it's a similar example. So what one programmer can do in a month, two programmers can do in 2 months. Okay, so it's a different thing, but let's keep this statement at hand and let's see what happens if we keep adding more people, okay? So this increasing part, or maybe here we can see it better. So this increasing part in marginal productivity, when the scale is fixed, so when the capital is fixed, so this equipment and the place and everything, right? Then we see that until a certain point, we can increase productivity only by using this specialization, right? So that you can think about this as a teamwork, you can think about this as separating work into certain tasks that people can increase their productivity, right? But there's a limit to it. So that if you keep adding more people to a very small place, right? So that, okay, until a point, they might specialize where they can work together. But if you keep adding, right, what we see is that their productivity is actually decreasing. So if like one person cuts only tomatoes, one person cuts only, let's say, I don't know, so lettuce, whatever we use for sandwiches, or chicken, whatever sandwiches you produce. But there's a limit to this specialization. And if you keep adding more people, then you will see that then you cannot fit, let's say, 6 people in this production site, right? Because the capital is fixed. So you cannot increase the size. Then if you add a lot of people, then, and if you keep adding, so if you try to put 20 people in this production site, so you cannot actually produce anything, right? So that's why we see that after a certain point, the productivity starts to diminish. And it will be harder to organize these people. It will be harder to proctor these people, so that we will see this diminishing return as we continue to add more people. So maybe for programmers, there's no point in specialization, so that we don't see this increase in production, increase in productivity, marginal productivity, but we directly see a decreasing point. So it depends on the type of production we have and the opportunities for specialization. So every production process is unique in that sense. So it depends what kind of organization that we have. So, okay, I can understand the statement. It does. So, but it depends also on the size of the project, right? So if you are producing a, let's say, a game, for example, then you have to specialize. I mean, so that the visuals has to be made by some other people, so some other programmers. So this sound effects has to be done by some other guy and such, right? So that there is a specialization. Okay, maybe you're not working in the same place, but there is still a specialization. So if you take one guy who can only know about, let's say, the engine of the games, let's say, I don't know, so who is in more the hardware part, and if you expect this guy to do also the visuals, then it would be hard for him to produce this game, right? But there is still a room for specialization, even in programming, but it depends on the scale of the program that we are talking about. Okay. So now let's go back to the problem of profit maximization. But again, before we can do it, graphically or mathematically, or maybe let's do it first mathematically and then we can do it. Yeah, then we can do it graphically. Okay. So remember that the problem of the firm is to maximize some profit, right? And for now, let's just forget about the opportunity cost. So there are no implicit costs, let's say. And the problem is to decide how much to produce. Sorry. So then this is P, or maybe let me write it like. Yeah, I'm a bit slack about notation, but I think we will understand. So I would like to produce some amount of product, and I know that the price of this output is P, and in return, what do I pay? I hire some labor and I pay W for these guys, and then I need to have some capital, and I will pay the interest rate for this capital, for each unit of this capital, right? So then what do I choose? I choose, so I can write, because I know, depending on the number of labor that I hire and number of capital that I hire, I know what production I will undertake, right? So I can also write this as, if I have the production function, I can also use this production function to determine my total output. Then my problem becomes this. Now I would like to maximize this profit. And what should I choose in order to maximize this profit? What is my choice variable in this problem? So wage is a price. Yes, Alperen, you're right. Wages are prices. So, and we are operating in a perfectly competitive market. So for this firm, wages what? Wages given, so that you cannot play around with wage, okay? Because you don't have any control over prices if you are talking about a perfectly competitive market. So if you're a monopson, which means that you are the only firm who hires labor, then you might actually control wages, but then it is not a perfectly competitive market. Okay? So, but my choice variables are actually the number of labor and number of capital that I would like to use in production. So, is this a constraint problem or an unconstrained problem? What do you think? We have a constraint. I mean, without a constraint, there's no economics, right? We'll come to the curves. We are not there yet. It's just a mathematical expression. Okay. So when I write this explicitly, actually I use the constraint. Constraint here is my production technology, if you like. Because here, when I use this, okay. Utku, actually, by choosing labor and capital, actually, I'm trying to use capital and labor most effectively, meaning that I would like to produce this with the minimum possible cost that I could bear. So in that sense, lowering production costs is somehow included in this, because remember, on the one hand side, we have production, and on the other, we have the cost of production. Yes, now you see it. Because prices are given, don't forget. So the firm, when she tries to solve this problem, she takes, okay, she knows what the price of the output is, and she knows what the wage rate and interest rate are, okay? But here, I did something explicitly. I say that, okay, the main problem is actually with some given prices, I would like to produce some good. And in order to produce, I have to use some labor and capital, okay? But here, the constraint is actually my technology, and technology is given by the production function, right? So this is the constraint here. But since I know that I would like to produce as much as possible, so typically what we have in mind is that my total product with a certain amount of capital and labor has to be lower or equal to this production possibility. Okay? But a rational firm would do, a profit maximizing firm would like to use this capital and labor most efficiently, and that's why instead of an inequality, I can say that, okay, this has to be equal, so if I can produce, I should be producing more, right? So that's why I could use this constraint directly in the objective function so that I can get rid of this constraint and I can directly write this problem as I did before, okay? So the constraint here is your technology, okay? And we choose capital and labor in order to maximize this profit. So what do we do now? How can I show the profit maximization conditions? What should I do? P is the price that I'm right. Y is the total amount of production. And the production function, this F, gives me or represents my production technology. So Y, okay, let me write like this. Number of products that I produce and sell. So P, price of the product. K, amount of capital. L, amount of labor. W are prices of inputs. And F is the technology. Okay. So yeah, okay, maybe I don't confuse you anymore. But this technology actually is similar to what Robinson Crusoe had, right? He had some skills, and with a given amount of time, so in his production function, what was the input? So, I mean, I write it explicitly, so it could be anything. So you could write it like, I don't know. So this could be a linear production function. It could be a geometric average kind of production function of order 1. And it could be more general, so that it's still a geometric average, but that has something like this. But it could be anything, okay? So it depends on what kind of production I'm talking about. It's just a production function. So you put capital and labor, and you know what is the translated output, okay? So, but just to give an understanding about why production or technology is a constraint, remember the production possibilities frontier that we had before. So it was something like this, right? And for Robinson Crusoe case, the production function here was a function of time, right? And we know what she could produce, what he could produce by using his time with his given endowments, right? Or with given his skills. So, and the production set or the opportunity set was the whole area below this line, right? So suppose that you have 100 labor, 100 worker in your production side, and you have some capital, some utilities, some computers or whatever. So can you produce 0 with these inputs? Potentially. Is it possible? Right? But you wouldn't choose to do that, right? So what's the point then? Then what we assume is that your production is actually at the point where you make full use of your inputs, right? So that's why instead of writing this as an inequality, I use the equality sign. Okay, thanks, Fatih. Okay, so that's why I don't write this as an inequality constraint, but rather a equality constraint, because I know that a profit maximizing firm should make full use of these resources that it has. Okay, that's why I say that it's an equality. Okay, so now I described my problem only by using the number of inputs that the firm has to choose. So, but what should I do now? What is the math that I have to do now? So the problem is well defined, right? And yes. So now I don't have constraints, so I don't need Lagrangian technically. Or if you like the Lagrangian, then I can say that Lagrangian is equal to P, the pi, minus lambda times 0. If you like. But no, I mean, I don't need Lagrangian here. Because I got rid of the constraint already. That is very true. So that how do we call these gradients? What kind of conditions are these now? What order, which order conditions that we have to derive now first? So Utku says we have to find the derivatives of this objective function with respect to what? Yes, with respect to our choice variables, right? So let's do that. So the P is a parameter, is given. Then I have to get the gradient with respect to K. Here I have this guy, and here I have R. And let us get the first order derivative with respect to L as well, which is equal to L minus W. So what is the condition that has to be satisfied in order to know that this is a local optimum? Yes. So these are called as the first order conditions for optimization, right? Okay, let's give a break.
Evet hocam.
Tamam, süper. But the problem is the same. I mean, it's a simple optimization problem once again. I mean, of course, I'm not going into details about the production function. So, I mean, what we assume here is that the first order conditions are necessary and also sufficient, meaning that the second order conditions hold. So, I mean, shortly, it refers to the fact that this production function has to be quasi-concave in order for this first order conditions to be sufficient, so that what we find is a local maximum. But this is we just assume. Okay, so we are not trying exact mathematical expressions here, but rather to have an understanding about the maximization problem at hand. So okay. So we had given a name to this first order derivatives, and how we called this. So, I mean, we had seen this for labor, but we could say the same for the capital. And how is this called? So in the household case, it was something like marginal utility, right? Instead of the production function, we had a utility function. Now we have the production function, so that we know that it's kind of an increasing function, monotonically increasing function with the argument. So it refers to the marginal change or a incremental change in the total production as we increased the amount of labor. So how is it called? How did we define it? Any guess? Any idea? Elasticity. Where did I talk about elasticity? So if you don't see percentage changes, then it means that we're not talking about elasticity. It is a more marginal product, and the derivative with respect to labor is the marginal product of labor. And if we use the same exactly, and if for the capital, then we are going to define it as marginal product of capital. So, okay, if we do the calculation, that what you have is this condition, sorry. So these two conditions, actually, if you look at them separately, we already see some intuition behind this. So this marginal capital of labor, remember the definition, it was the increase in total product as we increased the amount of capital by 1 unit. So this is the change in product, right? And if you multiply this by the price of product, we say that this is the marginal value product of capital. So which says that if I increase the amount of capital in production, this is the money that I earn. So this is the additional profit that I get by hiring this new amount of capital. And it says that it has to be equal to the interest rate. And interest rate is the price that I pay for this additional capital, right? So, so there are two things on the one hand. On the left-hand side, what I have, so if I increase amount of capital by 1 unit, so the firm gets P times marginal product of capital, right? But with this increase, I also know that I have to pay the interest rate to this. Okay, and it says that so the difference between these two has to be equal to 0. So suppose that it's not equal to 0, or let's say that the marginal value product of capital is higher than the interest rate. So that as a firm, what you should do then? What would you do? So this condition, so when we don't have equality, but now we say that the marginal product of capital times the price is higher than the interest rate. So if you were the entrepreneur, if you were the manager, what would you do? Eren, we are in a perfectly competitive market. What does it mean? Yes, prices are given, so you cannot decrease the price. But what you can change, so what is your choice variables? What are your choice variables? What can you choose? Yes, you can choose how much capital to use, right? Now I say that at a certain level, the marginal product of capital times the price is higher than the interest rate. So then you look at this capital level and you see that the marginal product of capital times the price is higher than the interest rate. So as the manager, how would you change the amount of capital that you use? Would you increase it or would you decrease it? Increase, right? Because you know that if I use more capital, then the revenue that I would get from this additional use of capital is higher than the price that I pay for this capital. So that increasing capital should increase my profit, right? And the same could be told for the labor. So, but what happens is you keep increasing the amount of capital that you use. So you increase it, it's nice so that you have a higher profit and you keep increasing. What happens then? So remember that the prices are given. So R is fixed, P is fixed. These are determined in the market. But what happens to this marginal product of capital is we keep increasing the amount of capital that we use. Yes, so the diminishing is the return, right? So there is an increase in the total product, but you say that it's a diminishing increasing. And what does it imply for the marginal product of capital? That as you use more capital in production, then what happens to this marginal product of capital? Does it decrease or increase? It decreases, right? So that if this condition is the case, then what I do as a firm, I increase the use of capital in the production, but I know that this marginal product will start to decrease as I use more capital. Then where do I stop? I do stop when this guy is equal to the cost of capital, right? Is that correct? So that is the intuition behind these first order conditions. Now we can also understand the relationship between the use of capital and use of labor. So if you divide these two by both sides, and what we have is the following. Right? So do you remember this condition from the household problem? So instead of these marginal capital of labor and marginal product of capital and marginal product of labor, we had marginal utilities, and on the right hand side we had prices. So it is similar actually. So we can also write it like this. We can say that marginal product of capital divided by the interest rate has to be equal to marginal product of labor divided by its price, which is the wage rate. Correct? So that what does it tell to me? Actually, it gives me an understanding about the optimal allocation of resources among capital and labor. So it says that, so this is the price that I pay for the last unit of capital, and this is the product that I get in return, right? And the same for the labor. So I pay for the last unit of labor a wage, and in return, I get the marginal product of labor. So it's the change in the production, so it's total production, right? So that the condition tells me that if you would like to choose how much capital and how much labor to use in production, then the return from the money that you pay to these factors of production has to be equal. Again, if we see that, for example, the marginal product of capital divided by the interest rate is higher than marginal product of labor divided by the wage, then what should firm do? Then it should start using more capital in production instead of labor, because what you get from capital is higher than what you get from labor. So that this is another condition, actually it's a combination of these two conditions that has to hold if you would like to maximize our profit. So this is the mathematical derivation. But now let us look at the graphical representation of these relationships. And in order to do that, similar to indifference curves and the budget line, we have to define something that represents the costs and the production. Okay, so let us start with the production. So how many dimensions should I need in order to represent this technology? It is a 3D relationship, right? So what I have is, oops, okay, let's say I have labor here, capital here, and total production here. Okay, so that, okay, it's going to look like a weird plane, but let's say that we only have a concave part of the function, so that, and my 3D drawing is really bad, so that, but at the end of the day, what I would see is some kind of a plane here, right? So that what it means, if I keep labor fixed and if I increase capital, then the total product should increase with a decreasing rate. And the same is true for capital, for labor. If I keep capital fixed and if I increase labor, so the total production should increase with a decreasing rate. Okay. But what I would like to understand is the allocation of capital and labor when I would like to produce a certain amount of goods. So in order to do that, let me choose a production level, let's say Y1. And I would like to understand for this production level, the amounts of capital and labor I could use to produce exactly this amount of product, right? So then I get a slice of this plane. Now it is two-dimensional, right? Now what I have is labor and capital, okay? And if this function is quasi-concave, do you know what the upper contour is? Does anybody know what a upper contour is? Upper contour is actually the set. Okay, it's actually the set that lies above this level. So, but I know if this function is quasi-concave, then the upper contour set has to be convex, which means in return, the level curve that I have to drive has to be convex. So the upper contour is this line and any point that lies above this line. So this is upper contour. Okay. But I mean, what I need is not this upper contour in particular, but what I need is the this level curve. So what do we know about this level curve? So this is a slice that I took from here and I bring it to a two-dimensional space. And this represents all these capital and labor combinations that gives me this exact level of production. So you know this is a level curve, right? But in production, and how did we call this in the household side when we talked about utilities? How was this called? How did we call this? It was called as indifference curve. So when we talk about production, this level curve is called as the isoquant, right? So it gives me the same, iso means the same, right? And quant it stands for quantity. So these are the combinations of labor and capital that gives me the same level of production quantity, okay? So, and if I know that this production function is monotonically increasing, then what I know from for the level curves is that a higher level curve, a higher isoquant, represents a higher level of production, meaning that if I see an isoquant that lies above another isoquant, then the production level that this presents is higher than the production level of the second isoquant. Okay? Okay, so this is about the isoquant. So it's the graph that shows all combinations of capital and labor that can be used to produce a certain amount of product. So now let us also think about the isocost curves. So here, what I would like to understand, the total amount of explicit costs so upper contour is a set, okay? So each indifference curve or each level curve has an upper contour. So the set is that, so is the points that lie, so let me draw it again. So it is the set of points, so all these points that includes the line itself, plus all these points that gives a higher quantity that is represented by this level curve. So this is the upper contour, okay? So what I said before was that if the function, so this f function, is quasi-concave, then the upper contour set has to be convex. So this set has to be convex. So a set being convex is somehow different than a function being convex, okay? So do you know what a convex set is? Okay, don't get confused with this. I mean, I just thought that you might have some knowledge about because you knew level curves, I thought you might also know the contour set, but okay, you don't have set here, all right. Okay, so so this is isoquants. I mean, all we have to know is that they are kind of convex, so they are decreasing. This is all we have to know about the isoquants for now. But now let us look at the ISO costs. So let us forget about the implicit costs for now, and let us focus on the explicit costs. So what is the total amount of cost? So it is the total wages that I pay for labor. So it's W times, so it's the price of labor times the amount of labor that I use. And it's the price of capital, then the total amount of capital that I hire in production, right? So let's say this gives me the total cost. Okay? So suppose that I have a certain amount of total cost. So let's say my total cost is 1,000. Okay. So what is the amount of labor and capital and the combinations of labor and capital that I could hire if I were to bear the same level of cost? Okay. So what I mean by that, I know that I'm going to spend 1,000 for hiring labor and capital. So what I would like to understand now is that what is the number of capital and labor that I could hire in production by using this amount of money that I have. So if I would spend all this money only for buying capital, let's say I spend this 1,000 whatever, or I don't know, 1 million euros, whatever, just buying computers for production. So we are going to produce a program, and we need to hire some programmers and also some very powerful computers and such. So I would like to understand how the costs look like, right? So now if I know the price of the computers, let's say it's R, then with a given level of total cost, I can know how many capital I could hire. So let's say R is equal to 100, right? So then the total capital that I could hire with this amount of money is, let's say, 10, right? So it's the total cost divided by the price of capital. And the same could be asked for labor. So what is the amount of programmer that I could hire for a given amount of time with this amount of money? So let's say that each programmer wants, let's say, 200 liras. Then if I would spend all this money only for the programmers, then I would get 5 programmers for this project, right? And if I combine all the combinations that I could hire with this amount of money, then this would give me the ISO cost line. So this is the ISO cost line for, let's say, total cost equals to 1,000. Okay. So now, so the prices are given, right? So if I would ask the same for a different cost level, let's say 2,000, so how can I draw it? Any guess? So it's away from the origin, and should it be parallel or should it be a different slope? It's supposed to be parallel, and the reason is the following. So the reason is, what is the slope of this curve, of this line, right? What is the slope of the ISO cost line? Slope could be fine. So it is a negatively sloped line, right? And I know that this intersection is divided by R. And then here I have, so it is this guy over here. And the slope of the ISO cost line is simply the ratio between wages and interest rates. And there's a negative because it's a negatively sloped curve, right? Okay. So if I would draw another ISO cost line for a different cost level, then it is a parallel shift because I spent more money, but the price ratio, so the relative prices of capital and labor, does not change. But if, for example, the wage rate decreases, then I will see that the slope of this ISO cost line would also change, right? Okay, great. So now the problem is the following. So the firm, suppose that, knows how many products it would like to produce. Let's say the firm wants to produce, I don't know, let's say 100 units of, I don't know, 100 sandwiches or 100 computers or whatever the production is about. So now what I would like to understand, how should I choose labor and capital optimally so that my profit is the highest in order to produce this certain amount of quantity, okay? So now I know that W and R, so that I know that one of my ISO cost lines will look like this, okay? So, for example, I could spend, let's say, total cost 0, and with this total cost, I could produce this Y1 amount, right? At these points, let's say A and B. But should the firm choose A or B in order to produce this amount of good? What do you think? Or can the firm do better? Right? Because I could produce the same amount by a lower amount of cost, right? So I can find another cost line, ISO cost line, that still passes through this ISO quant, right? Okay, suppose that these are parallel. And here at point C, I can still produce the same amount of product, but with a lower cost, okay? So again, we find a tangent point, and we know that at a tangent point, if a line is tangent to a curve, what do we know? That the slope of the line at this point has to be equal to slope of the curve at this point. So we know the slope of the line. What is the slope of the line? It is minus W divided by R. But then we have to find the slope of this curve, right? So what do we have to know? We know that this ISO quant, so this level curve, represents a three-dimensional function that is given by this guy over here. But this exact indifference curve that I'm looking after is a given amount of production, which is Y1, okay? And what do I need to find in order to find the slope of the curve? If I look at the axis, then what I'm looking at, what I'm trying to find is this derivative, actually, right? Exactly. So I have to derive this guy, and I can derive it by finding the total derivative. Then if I get the total derivative, so what I know about the left-hand side is that since I am operating on a given level, so the change in total production on this curve has to be equal to what? Zero, because I know that this is scalar, right? So this y1 is a scalar, so that the change in the scalar has to be 0. Then I know the name for this guy and the name for this guy, right? And if you do the calculation, what you see is that, so this slope is given by this ratio once again, right? And this optimality condition should satisfy that these two slopes has to be equal to each other, right? Then we can again derive the condition such that the ratio between marginal productivities has to be equal to the ratio between the price of these inputs. And this rate of marginal productivities we call marginal rate of. So remember, in the household case, it was the marginal rate of substitution because it would rate when the utility was the same, it would rate of substitution between two different goods. But now the rate that I am calculating here with this ratio is the rate of substitution between different inputs in a production technology. That's why I call it marginal rate of technical substitution. Which would tell me what is the rate that I could substitute capital with labor in order to produce the same amount of product. Okay, and okay, I didn't put it here, but what should I know about marginal rate of technical substitution is that if there is diminishing returns, then I would have a decreasing rate of technical substitution, marginal rate of technical substitution. And the reason is, as I hire more labor, it would be harder for it to substitute for capital. Because again, if you think about the programming project that we have, okay, you can use a lot of labor, a lot of programmer, but if you don't give them any computer, they cannot do anything, right? So that as you transfer your budget towards programmer, maybe in the beginning, the amount of computer that you have to decrease could be higher because programmers are more effective when you use just a little programmer. But then if you spend all your money only on programmers, then the amount of programmer that you have to hire in order to produce the same amount of output should be higher because the productivity, marginal productivity of labor should be decreasing. And in return, what we have is a decreasing marginal rate of technical substitution, which is due to the, which also refers to this convex shape of the isoquant curve. So that what I mean, once again, or maybe let me draw it in another graph. Is the following. Sorry. Is the following. So that I'm on the same isoquant, and let us compare A, B, and C. Okay. So that if I move from point A to point B, what do? I increase the amount of labor that I use, and in return, in order to stay in the same production level, I have to decrease the amount of capital by a certain amount. So if I keep increasing the amount of labor with the same rate, let's say, or maybe put it here. So I increase the same amount of labor, but now the amount of capital that I have to decrease is higher now, right? And the reason is, in order to stay in the same production level. And the reason is, in the beginning, the productivity of capital was low because I was using a lot of capital, right? So by increasing a bit of labor, I didn't have to decrease the amount of capital too much, because the amount of substitution was already high. But as I use more labor instead of capital, so that in order to stay in the same production level, the rate of substitution is decreasing. So in order to increase the same amount of labor, the amount that I have to decrease from capital is also decreasing. It was a bit confusing, no? Let me try once again. Sorry, I was distracted by the phone call. I was expecting a phone call. So let me try it once again, and then I will release you. Okay. Let me try once again. Okay. So what I do is the following. So I increase the amount of labor at the same rate from A to B and B to C, right? So what do I see here? So I stay on the same production level. And in the beginning, the use of labor is low, right? So let's say this is LA, LB, and LC. Okay. So in the beginning, since I'm using just a little labor, so the marginal product of labor is high, that if I increase from LA to LB, the increase in production is large, right? Then in order to compensate for this increase, because I want to stay at the same production level, so the number of capital that I have to decrease is also high, right? Because the productivity of labor is high. But if I would like to do the same, so I increase the labor with the same amount, now the marginal product of labor is lower as compared to the first case because I'm using more labor now, right? Then the amount of capital that I have to decrease in order to stay at the same production level is also lower, okay? And if you keep doing it, you will see that the rate of substitution between capital and labor is decreasing as I use more labor in production. So that's due to the diminishing returns, and we call this law of diminishing marginal rate of technical substitution. That's all I wanted